Okay, and welcome back to the second video for section P5, factoring. Factoring is a big deal in algebra, and it is a bottom line factoring is a big deal for algebra, and it is a core concept that you absolutely have got to know. All the way through calculus. Calculus students struggle with factoring, and it really does affect them negatively. And so we really got to get that factoring stuff down. So we're going to talk about, the last video talked about many of these objectives. We're going to focus on the basic trinomial factoring, okay? And we're going to look at those in a couple of different ways. All right, that will include perfect square trinomials. I do not teach perfect square trinomials separately. I don't think that they should be thought of as separately. And we'll talk about a general strategy for factoring polynomials. We'll also talk about factoring polynomials that have fractional or negative exponents, not polynomials, sorry, algebraic expressions. They're not polynomials by definition, right? But you can use the same principles of polynomial factoring for other types of factoring, and I'll show you what that looks like here at the end of the video. So here's an example of how to factor a trinomial whose leading coefficient is equal to 1. And if it's equal to 1, then basically this is kind of a guess and check kind of deal, because the x squared obviously is just x times x, right? So what we're really factoring is the 40, and we're looking at factor pairs of 40. So numbers, whole numbers, right, that multiply together to give you 40. So 1 times 40, 2 times 20, 4 times 10, and 5 times 3. Those are the only four that multiply together to give you 40. All right, and then because this is a plus 40, typo there, sorry, then because this is a plus 40, we're going to be adding the terms together to get the middle term. So which of these product factors give you a 13 in the middle? 5 times 8, that's 40, and 5 plus 8, that's 13. And so we break this up into x plus 5 and x plus 8. And that's how it factors, okay? Now, again, that really only works well for polynomials with 1 in the front of the x squared with a coefficient of 1. But I want to show you another method that's not in the textbook. This is called the AC method, and this is used more often when you're factoring ones with not a 1 in front of the x squared, with a non-1 here, 3 in this case. All right, so how does the AC method work? Well, if you remember, the general form of a quadratic is ax squared plus bx plus c. And so a is the number in front of the x squared, and c is the term here that's constant, and we're going to take those two terms and we're going to multiply them together. All right, so a times c in my case is 21. 3 times 7 is 21. Okay, so now what I'm going to do is I am going to write all the factor pairs, just like we did before, all the factor pairs of 21. In this case, there's only two. 1 times 21, 3 times 7. And again, if this is a positive, then we're going to add to get the middle. And so the middle is negative 10. And so which of these two guys will add together to give you 10? 3 and 7 add together and give you 10. And so negative 10 is going to come from negative 3 plus negative 7. And so what we're going to do is we're going to break down, we're going to undo the FOIL method. And by undoing the foiling method, what that means is we're going to rewrite this as negative 3x and negative 7x. Okay? And so I know this looks a little bit weird, and if you can do it in your head, that's great, but most people can't. And so now what do we have? What we have is we have 4 terms, and the way that we typically do this with 4 terms is we factor by grouping. All right, so we're going to group these two guys together. Remember factoring by grouping from the last video. We get 3x squared minus 3x plus negative 7x plus 7. Okay, excuse the dog lapping in the background. And so what's our common factor in the first terms? Our common factor here is a 3 and an x. So we factor out the 3x. And what are we left with when we factor out 3x? If you divide 3x squared by 3x, you get an x. You divide 3x by 3x, you get a 1. What's in common to the second guy? 7 is in common, obviously, but we're going to factor out, again, we factor out the sign of the first one always, so we factor out the -7. And so in order to factor that out, you divide by -7, you're left with an x. 7 divided by -7 is -1. And if we did this correctly, and we did, we're left with x minus 1 as our common factor here. So we get an x minus 1 for the first factor, and then the second factor is what's left, 3x minus 7. And so that is our final answer. That is our perfectly factored trinomial 3x squared minus 10x plus 7, but it's done in a way that is very methodical and will always work. Again, depending on what this number is, if that number is 40 or 60 or something like that, you're going to have a lot of factor pairs, but still you're looking for the one factor pair that adds to be the middle if this is a plus, or if this happens to be a negative sign, you're looking to subtract to get to the middle. Okay, lots of practice problems are available online and in your worksheets from class on these. Okay, so that's how to factor. That's called the AC method for factoring trinomials. All right, so in general, we have the possibility of having to factor using combination of factoring rules. All right, so you're given this 8x cubed minus 18x, and you're asked to factor that completely. Okay, well, when I look at this guy, there's only two terms. So automatically, I start thinking, okay, there's only one of really two options. It's either a special difference or product, difference of sums, difference of cubes, whatever, or there's a common factor that I can pull out. Well, if you notice, this is not difference of cubes, because this is a cube, but this is not. This is x to the first power. Okay, so it's not difference of cubes. All right, so there must be something in common here that we can do, and obviously there is, what we're looking for, a GCF now. So there's an x in both terms, so the GCF is going to have an x. And then if you look, this is 4 times 2, and this is 18 is 9 times 2, and so there's a 2 in common as well. So 2x is our greatest common factor, so we're going to factor out the 2x. When you factor that out, you're dividing out 2x. What are you left with? Well, if you divide this by 2, you get 4. X cubed divided by x is x squared minus, and then if you take 18x and divide it by 2x, you're left with 9. So I get 4x squared minus 9. Now, aha, right? This guy here, this guy is 2x all squared. And this guy is 3 all squared. And so this is of that form a squared minus b squared, right? And so this is a difference of squares. And so we get the 2x is still out front, and then we get a 2x plus 3 and a 2x minus 3. And so this big ugly mess is the factored version of 8x cubed minus 18x. Okay, so one step at a time. If you can find a greatest common factor, that is the best way to start. But remember, a greatest common factor must be included in all of your terms. So if this had a plus, 11x cubed or squared, I guess I should say, right? That has an x in it, but it does not have a 2. So that's not your greatest common factor. Or if this was just an 11, there's no greatest common factor here at all because these are relatively prime. So greatest common factor only works if it's in common to everybody. Okay? Now the last thing I want to show you is that we can use factoring techniques for expressions that have fractional or negative exponents. They aren't polynomials, but they can still be simplified using factoring techniques. Okay, and so here's an example. We want to factor and simplify x times x minus 1 to the negative 1/2 plus x minus 1 to the positive 1/2. Obviously x minus 1 is what's in common here, but what do I do with these negative powers? How would I handle that? Well, let me take you back. If you had like a cubed minus 4a squared and you wanted to factor out the common a, what do? Well, you take the lowest power, right? A squared is what's in common because, and then when you factor that out, what happens? If I factor that out, I'm dividing, and so when I factor that out, I subtract my powers. So a squared divided out of a cubed leaves me with a to the first power. A squared divided by a squared is 1 and leaves me with a 4 times 1, and so I can factor it out like that. I'm going to do the same thing here. My common factor is x minus 1. The lower power is negative 1/2. And so the smaller exponent means the greatest common factor is x minus 1 to the negative 1/2. Now what does that look like when I factor it out? If I factor that out, okay, then I divide it away, I'm left with x here, but I'm not going to think of it like this. I'm going to think of this as x to the minus 1/2 to the positive 1/2, and if I'm factoring out the negative 1/2, what do I do with the powers? I take 1/2 minus negative 1/2, and I get a plus 1. So I'm left with x and x minus 1 to the first power. And then obviously that simplifies down to 2x minus 1. And then you can put it in the denominator if you want to, but you don't have to do that. Okay, we're not going to do a lot with that, but that's something that you will see as you move forward to your more advanced classes. In pre-calculus, you probably won't see that, but in calculus, you need to understand how to handle negative and fractional exponents when you're factoring. And so just a nice little base for you to have and a little bonus for right now. Okay, thanks. See you next time.